Bismillahirrahmanirrahim. Welcome to Bagh School. This is Physics Department, grade lesson number 11. Dear students, in this lesson we are going to discuss the past paper problems which are relating to the units which we have just finished, that is electricity, practical electricity, electric circuits and DC circuits. So relating to these problems, we will solve the problems from the past papers. So the first is from the year 2018 May-June, and the paper is 22. In this problem, there are two resistors, 10 ohm and 40 ohm. So they are in series, and the potential difference of 40 ohm resistance is given, that is 9.6 volt. So the question is that what is meant by potential difference across a resistor. Dear students, as we know that the potential difference of the battery total energy which is can be supplied by the battery is called EMF, and that EMF is dissipated across the resistors in the series circuit. So the potential difference across the resistor is the amount of energy transferred in another form. For example, in the bulb we transfer electrical energy into heat and light energy. So this is also called the potential difference across the resistor or across the bulb, or it is also called the potential drop. So this is actually amount of energy transferred in taking unit charge through the resistor. So this is also called potential drop or energy dissipated. Now the second part is that they calculate the current in the 40 ohm resistor. The 40 ohm means resistance is given, the potential drop difference or potential drop is given 9.6 volt. So with the help of the Ohm's law formula, I is equal to V over R, we can find the current, which becomes 0.24 ampere. So dear students, 40 ohm and 10 ohm, they are already in series. So the same current will be passing from 40 ohm and 10 ohm because only one path is given. That is 2.24 ampere will pass through 40 ohm, and same the current 0.24 will pass through 10 ohm. Now we want to calculate the electromotive force or EMF or the potential difference of the battery. The EMF is the equal to the total the potential across 40 ohm and 10 ohm. So the total resistance becomes 50 ohm, and current passing through these two resistors is 0.24 ohm. So that becomes EMF is equal to V is equal to IR. So I is 0.24 multiplied by 50, that becomes 12 volt. So that the battery is actually supplying 12 volt potential difference. And the C part is that the student has 3 different voltmeter to measure the potential difference across the 40 ohm resistor. So these are labeled 0 to 2 volt or 0 to 20 volt and 0 to 200 volt. Each has a pointer that shows the potential difference on the scale. State and explain which of the 3 voltmeter is best to measure the potential difference. As we know that the potential difference across 40 ohm resistor is 9.6 volt. So 9.6 volt means we only need the that voltmeter which can go up to 10 volt or whatever the available minimum maximum value, and the minimum should be 0. So 0 to 2 is too low because the range it cannot measure 9.6 volt, so this voltmeter cannot be used. 0 to 20, yes, it can be used, and 0 to 200 volt, this is too high range, So we only 0 to 20 volt is possible to use for the measurement of potential difference across 40 ohm resistance. Okay, now the D part is calculate the power, and power formula is equal to P is equal to VI, and V is IR. So I into R into I, 0.24 into 10 into 0.24.58. Okay, now there is another question that there are two resistors which are half of the power of the and double of the power. So why half of the power is not suitable for the circuit in this figure? So as we can understand that if 0.58 is reduced to half, that resistor is being used, then it will blow up because the total power is 0.58, which is coming from the battery. So that resistor might not be suitable to use. Yes, double power resistor can be used because then it will not blow, though it will not consume the full energy, but it will not blow. All right. So there is another question that the students add the resistor R to the circuit to make the circuit as shown in the figure. So he has added a resistor parallel to 40 ohm. Interestingly, if we add a resistor across the parallel to any resistor, then the total resistance of these two resistor is reduced because they are in parallel, and in series the resistors are adds up. So we actually want to find the values remaining in the table. The first thing is the current in 10 ohm resistance already given is an increase. Why? Because the total resistance decreases. When the resistance added to parallel to the 40 ohm, their total will be less than 40 ohm. So when it is less, so it means the total resistance is reduced from 50. It will be less than 50. If resistance is reduced, current will be increased. So that is the reason when current is increased, it means the total resistance decreases. Now the potential difference across the 10 ohm resistor, that will increase definitely because the parallel resistance are less, so their potential difference V is equal to IR will be less, and that is why the potential difference across 10 ohm resistor will increase as the total resistance of the two parallel decreases. Similarly, the potential difference across 40 ohm that will be decreases because the total resistance of two parallel decreases. Okay, so now we go to another question. A student measure the resistance of a lamp when there are you see different currents in the lamp, and she sets up the circuit as shown in the figure. Still there is a simple lamp and a variable resistor, so the resistance can be varied. Now she adjusts the variable resistor until she obtains the reading on the voltmeter scale and ammeter scale as given. So you can see that the voltmeter showing the 1.6 volt, and ampere meter is showing that the point that is 0.85. So 0.85 volt is being shown by the ammeter ampere, and the voltmeter showing 1.6 volt. Okay, now the first question is that draw the symbol for a voltmeter connected to measure the potential difference across the lamp. So across the lamp, the voltmeter is connected. In the circle, there will be a V, the symbol of the volts. B part it said that he adjusted the variable resistor and gets a reading. So it means the voltmeter reading will be 1.6 volt and ammeter reading will be 0.85 volt. So we can, from here we can find the resistance of the uh, lamp. Okay. So when the resistance of the lamp is measured, that is V over I, 1.6 volt divided by 0.85. The second reading, he has already given that the 0.83, the potential difference is reduced and the current also reduces. So the resistance is 0.83 divided by 0.11. So the second reading gives us uh, this value. Okay. Now, dear students, I have left two parts for you. You need to think and give me the answers of these questions and send me on my WhatsApp. Thank you very much.